Hi, welcome to Global Azure Spain. We're going to look at choosing from the many ways to Docker in Azure. Come join us. This is the part where I tell you I'm definitely going to post the slides on my site tonight. And I've been that person chasing the speaker, and they never posted it either. Which is why you can go to robrich.org right now and take a look at the slides. Here's robrich.org. Click on Presentations, choosing from the many ways to Docker in Azure. Here's the slides that we're going to look at right now. While we're here on robrich.org, let's click on About Me and talk about some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate. AZ GiveCamp is really cool. AZ GiveCamp brings volunteer developers together to build free software for charities. We start Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Monday morning, we go back to work. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp in your area, hit me up on email or Twitter, and let's get philanthropy installed here in Spain or wherever you're connecting from. Some of the other things that I've done, SQL Source Control Basics, mine is Chapter 8. That was a lot of fun. And I replied to a .NET Rocks podcast episode. They read my comment in the air. They sent me a mug. Woohoo! So there's my claim to fame. So let's dig into the many ways to Docker in Azure. There's a lot of different solutions for running containers in Azure. And, well, how do we know which one to choose? Let's look at each of these and figure out where it makes sense. Before we do that, let's take a brief look at Docker and level set a little bit to understand what we're here for. Docker is a container virtualization platform. Containers virtualize the kernel, the operating system, instead of the hardware. So Docker is this suite of tools that make running and building containers easy. That's great. On the left, we have a traditional virtual machine type environment. On the right, we have containers. We can see that we've got a lot of space taken up for operating systems here on the left, and, well, maybe that's a lot of wasted space. If we choose to virtualize the operating system, we only need that portion of the app that runs our content here on the right. We can see that already, and this isn't to scale, we're running a lot more content on the same hardware. That's a net win. So, containers. We virtualize the operating system. That means that the container's operating system needs to match the host's operating system. We'll run Linux containers on a Linux host, and we'll run Windows containers on a Windows Server host. Well, what about Mac and Windows Desktop? Well, in that case, we'll probably run them like this. Now here on the right, we'll run this way in production, as dense and as tight as possible. But in development, we'll run it here on the left. Now we'll take our regular machine. Here's my Windows 10 laptop. I'll install the host operating system. So there's my Windows 10 machine. I'll install the regular hypervisor. On Mac, this is HyperKit. On Windows, it's Hyper-V. And then I'll install my guest OS. And inside that guest OS, a Linux virtual machine, I'll install the Docker engine, the Docker hypervisor, and then run my containers there. If I'm on Windows with WSL2, I can make this WSL2 and install Docker inside of WSL2. That's great. Now, because I have this hypervisor, I can also run other virtual machines here if I'd like. But now I have the ability to run Linux virtual machines on my Windows machine. In production, we still want to do it here, like on the right, as densely as possible. But in development, now I can run Linux containers on a Mac or a Windows desktop. That's great. So now let's add in an orchestrator. An orchestrator is that piece that runs containers at scale. So we'll use both Docker and Kubernetes together, for example. So what is an orchestrator? An orchestrator, we will give it the desired state that we need. And the orchestrator will make it happen. For example, run 3 copies of my web server and make sure that they're always running. Now, desired state configuration is definitely a thing, and this isn't. This desired state is the desired state of containers. Run 3 copies of my web server together with the database that it needs. Run all of my microservices and keep them distributed across the network. These are requests that we'll hand to our container orchestrator, and it will just make them so. We don't need to worry about which actual machines it's running on. We just need to tell the orchestrator to do it. So here's some of the tasks that the orchestrator will do. Start and schedule a group of containers, distribute containers across the machines to ensure that they're across, for example, an availability zone, automatic or manual container scaling, monitor container health and restart the containers if anything happens. Oftentimes, they'll be able to load balance scaled containers, and they'll have a management user experience. These are things that we choose to outsource to our container orchestrator. So what is a container orchestrator? It's the thing that keeps our containers healthy so that we can go back to sleep. I don't want to get woken up when my machine goes down. I want to outsource that to this machine, my container orchestrator. So what are example container orchestrators? We have Kubernetes, we have DCOS, Docker Swarm, Service Fabric, Fargate. These are all examples of orchestration engines. With each one, we hand it our containers and we say, can you run these containers, please? And it'll take care of all the details of spreading them across our machines. The Docker ecosystem. With the Docker ecosystem, here's how we get from our code to a running container, perhaps on Kubernetes. We'll start with a Dockerfile. The configuration is code. This is the steps that we need to get our code into containers. We will build that into an image. Now this image could get shared with Docker Hub. We could pull images from Docker Hub. Unlike things that we might share on GitHub, this is not the source code, the Dockerfile. This is the built binary blob, which means I don't need to recompile it once I download the container from Docker Hub. We'll take this image and we'll run it as a container on a Docker hypervisor. Plug in Ethernet, plug in power, and we can start up this container really quickly. A Dockerfile built into an image, run as a container. Now I may choose to do this with many containers in concert through an orchestration engine as well. So let's go build up a container. Well, I have this empty folder. And we could go into Visual Studio and say file new project, but let's do it here from the command line. .NET new MVC -- name site -- output dot. Now it's going to scaffold up the website and get us all the things that we need. Let's open that up in VS Code, and we can see that we've got controllers, we've got views. Let's come into this one. Welcome to Azure, to Global Azure Spain. Perfect. Now to get this ready to save into source control, we'll need to create a gitignore file. Let's create a new file, .gitignore. Let's spell it correctly. .gitignore. And this is all of the content we don't want in our repository. Bin, obj, star.user, star.suo, the .vs folder. These are all the things that we build or user-specific settings. We don't want those in source control. Now, to get ready for containers, we'll create a similar file. Let's create a .dockerignore file. Now this dockerignore file is all the things that we don't want to end up in a production container. Well, all of those things. We're going to build inside the container, so we don't want old built content and user-specific settings. We also don't want this launchsettings.json or this appsettings.development.json. Appsettings.development.json and launchsettings.json. Now, launchsettings.json is all of the details that we need to debug our app. Not necessary in a production container. Now we've got our dockerignore file. Let's create a Dockerfile. Dockerfile. Now it's important that this is Dockerfile and not dockerfile.txt. So if you've named it dockerfile.txt, rename and set it in as Dockerfile. Let's go stand on the shoulders of giants. We'll head out to Docker Hub, search for .NET, and let's go look for the .NET repositories. Now we want to build inside of our container, so let's go grab the .NET SDK, and we will grab this content. Scrolling down, I can see various labels, versions, and I'll use the Alpine variant, 5.0-Alpine. Okay, so here's our content, Alpine. Now we'll copy in all of the content from the root directory where we run the docker build command to the current directory inside of our container. What is that directory? workdir/src. Now there's nothing magic about src, but that's convenient. Then we'll need to run some .NET commands. .NET restore, that will restore all our NuGet packages. .NET build -c release, that will do our build. .NET test, and .NET publish. Now this .NET publish is the same command that we would run if we right-clicked and published inside Visual Studio. But we're doing it here in a scripted build file, so we know we'll get the same results every time. Now we need to run these as Docker commands. So let's run them. There we go. Now we've got all of our content restored, built, tested, published. Now I'm going to leverage the power of Docker's layers and caching, and we'll say copy in site.csproj. And now if any of our NuGet packages change, we will re-restore them. But if our NuGet packages don't change, we will rebuild our application faster. Nice. Now let's start a new container. We'll go grab the ASP.NET Runtime container. And we'll go grab a few environment variables that will set us up nicely. We want to run in production, we want to run on port 80, and we'll expose port 80 so that others trying to consume it know what port to forward into. And then cmd, the command that we want to run .NET site.dll. Well, we need our site.dll to be in workdir/app. And so how do we get our content there? Well, let's copy it from this stage into this stage. Dist to our current directory. But right now, this copy command would copy from our host machine. We want to copy from equals build. And where is build? There's nothing magic about this name either. Let's call this one as build. Nice. We have a Dockerfile now that will do a multi-stage build. Here is our build server, misusing that term. And here is our production server, misusing that term again. We'll build a build image where all of our source code and content lives. Then we'll publish that final point into this really lightweight production runtime container. Great. So let's go do that. We now have all of our content in place, and let's Docker build, and we'll tag it with azurecr.io/Docker in Azure. We'll tag it with our Azure Container Registry name and give it a version. And what's our current directory where we build? This directory. Now this will do that Docker build process. So it's going to go copy all of our content into our container, restore all our NuGet packages, do a .NET build, .NET test, .NET publish, and we'll have our final image ready to go. Looks like it's doing the .NET build here. Let's see. Is our build going to pass? I don't know. Yep, it looks like it passed. Now how about our unit tests? What unit tests? Yep, all of the no unit tests that we have in the project succeeded. Let's do a .NET publish. Yep, that worked. And we've got our container, or our image. Here's our new image. Perfect. Now let's publish it. If I need to, I can say Docker login and pass in the container registry, but I've done that previously. So let's Docker push that container into place, and now that will send it up to Azure. Great. So while it's sending it up to Azure, let's take a look at what we saw. Well, we've got this process of doing that Docker registry, we got that process of getting into the Azure Container Registry. So the Azure Container Registry is, well, not that different from Docker Hub. Docker Hub is a registry, and there are other registries as well. Docker Hub is free for public images, and you can pay for hosting private images. By comparison, Azure Container Registry allows you to do private images where you can keep them within just your subscription. In this case, that's where I chose to publish my image. So we did that Azure Container Registry. Let me get logged into the Azure portal. And now we can see the container registry. Here's the container registry that we just pushed to. And so if we dig into the repositories, the containers, here's Docker in Azure, that one that we just pushed. Perfect. v0.1. Now we didn't push a latest tag, but we could definitely do that. Docker tag, here's that one, and we want to give it a latest. And let's Docker push latest into place as well. Well, in this case, layer already exists, and that went up really fast. That was cool. So Azure Container Registry gives us that exact same Docker Hub experience, but now private to our own subscription. Now let's look at the various ways that we can run containers in Azure. We have a lot of compute mechanisms in Azure, and we can run containers in most of them. As we look at it, we'll look at a graph kind of like this. Now, as we started with on-premise things, we owned everything. As we move into the cloud, we choose the various things that we want to outsource. When we look at infrastructure as a service, we outsource virtualization, servers, storage, and networking, but we still own the OS, the middleware, the runtime, the data. If we choose a platform as a service, then we outsource some more things, the runtime, the middleware, and the OS. If we use software as a service, we outsource everything. We just log into a website. Well, where do containers fit? Well, we can kind of fit them in between these stacks in various places. Here's infrastructure as a service, a virtual machine. Platform as a service, Azure Web Apps. Software as a service, well, Azure Functions kind of fit in the middle here, and containers kind of fit in the middle here. We'll see interesting ways where we can run them. With each of the Azure Compute platforms, we'll look at the various things that we choose to outsource and the various things that we choose to own. So, what do we want to outsource? Let's look at each of these environments and take a look at the various pieces. Azure Kubernetes Service, Azure Container Instance, Azure App Service, install Docker on virtual machines, or even Kubernetes on virtual machines. What do we want to outsource? That's what will help us lead to the right decision. Now, it may be different for your environment than for mine, so you may make different decisions about the things that you want to outsource versus the things that you want to own. Ultimately, what we're choosing is our orchestrator. Let's look at each of the Azure Compute mechanisms. For each, we'll look at what we've chosen to outsource and what we chose to own. We'll look at the pros and cons of these choices, and ultimately, when we would choose this mechanism. First up, let's look at Azure Container Service. Now, Azure Container Service was the first mechanism for running a container orchestrator inside of Azure. And, well, it's legacy. Azure Container Service was great. It was an ARM template that provided virtual machines for getting DCOS or Docker Swarm or Kubernetes running. Now, it was really cool in that it spun up all of those resources for you. But at that point, you owned all the virtual machines from then on. So it was great in getting them spun up quickly, but ultimately we wanted a little bit more outsourced than that. So Container Service We outsourced provisioning and the initial configuration, but all of the product updates and machine maintenance, we still owned that piece. And so Azure Container Service was retired some time ago. Now, if you were on Azure Container Service, you can move to Mesosphere Open Source, Docker Enterprise, or Azure Kubernetes Service, depending on the container orchestrator that you chose previously. As you grab these slides from rawrich.org, click through to each of these blue links, and you can go to the details associated with those particular services. Next up, let's look at Service Fabric. Now I'm going to mark this as legacy as well because, well, Service Fabric is weird. Now, that is definitely my opinion, but what's interesting about Service Fabric is it's the orchestrator that Azure uses under the hood to run Azure services. So it's definitely not going anywhere anytime soon. The new services may be built on Kubernetes or on Azure Service Fabric, but Azure Service Fabric is how Azure runs Azure. So it's definitely durable. But using it is kind of weird. There's some Visual Studio templates that create these pieces, and then from there you start to get to publishing into this dashboard, and it kind of has a Fargate-like experience where you pretty much outsource all of the running. I don't need to worry about virtual machines. I don't need to worry about how many nodes in my cluster. There's just one big cluster in the sky, and I just publish content to it. That's kind of interesting. But, well, it is kind of weird. The fact that I have to provision it inside of a Visual Studio project is just weird. So, Service Fabric. The cool thing is we've outsourced pretty much everything. The only thing we need to own is the process running inside of the container. When do we restart things? How do we scale them? All of the deployment details, all of that is owned by Service Fabric. That's pretty cool. If that's what you need, if you don't want to worry about the orchestrator, Service Fabric might be a great choice. So on the upside, there's no hardware to maintain. Azure manages everything. It works great with Windows or Linux. On the downside, it has a heavy focus on Windows. And so if you're hosting Windows containers, it's a natural fit. If you're hosting Linux containers, it works okay too. Service Fabric. When would you choose this? If you're mostly hosting on Windows, or you have an aversion to open source like Kubernetes. Next up, Azure Kubernetes Service, the big dog. Azure Kubernetes Service is great when you want to host a lot of microservices. It is real live upstream Kubernetes. It has a free managed control plane, so you don't pay for the control plane, you only pay for the worker nodes. You can then choose the size and quantity of the worker nodes, and at that point, then you just run them. Let's take a dig into Azure Kubernetes Service. So back here on the command line, I'm logged into my Kubernetes, Azure Kubernetes, kubectl get all, and there's my content running in Kubernetes. Right now, nothing. So let's spin up some stuff. Let's go look for some Kubernetes content. Set that in place. And go take a look at the Kubernetes content that we have. Now we have a deployment here. This deployment will take that Docker in Azure container and run it as a pod inside of Kubernetes. In this case, we're only running one. In front of the deployment, we have a service that will load balance across all of our pod instances. In this case, we only have one. And then we'll have an ingress in front of that that will match the DNS name associated with the service. So let's apply those into place. kubectl apply -f k8s service kubectl apply -f k8s deployment kubectl apply -f k8s ingress. And now let's go kubectl get all and ingress, and we can now see that all of that content is running. I've got my pod running, I've got my service running. Once DNS propagates, I'll be able to get to this container right there. But propagating DNS takes a bit. So let's head out to this blog post where we can take a look at port forwarding into Kubernetes. Now I could port forward into a particular pod or into a deployment or into replica set. In this case, let's port forward into a service. So let's say kubectl port forward service / Docker in Azure, and I'll go from port 80 on my machine to port 80 inside the container. Or if I've got something running on port 80, I'll go from port 8080 on my local machine to 80 in the container. Localhost 8080, and we can now see our container running in Azure. Perfect. Now that was Kubernetes service. So now if I say kubectl delete -f k8s, it will actually delete all the things in there. So it deletes the ingress and the service and the deployment. kubectl get all. And all of that content is coming down. Refresh the page, and of course, I'm going to get a not found. That content is now offline. That was great. We got to spin up Azure Kubernetes Service. Azure Kubernetes Service is great when you have lots of pieces and you need to spread out over real live Kubernetes. We chose to outsource the control plane. We outsourced container restarts. We outsourced node scaling. We choose to own the container process, the Kubernetes version, and we could choose to own node scaling as well. The cool part about that is inside the portal, we can choose the version of Kubernetes that we want to use. So let's come here. Let's take a look at our Kubernetes service and the version of Kubernetes that we're running. Configuration. Nope, that's not it. Cluster configuration. There we go. I'm running 1.19.7, but to upgrade that version, I could just choose a new version and click Save. All of the details of managing that cluster and doing that upgrade process are handled by Kubernetes. Now in this case, I'll choose not to. Great. Azure Kubernetes Service. It is real live Kubernetes. The control plane is free, and so I only pay for the VMs that I'm running. Windows and Linux, actually it's no longer in preview, you can run either Windows or Linux containers inside of Azure Kubernetes Service. You can do push button scaling, just go grab the slider and have it deploy more nodes or more containers, and push button cluster upgrades. On the downside, yeah, there was a lot of YAML involved. There's mechanisms of creating that or templating it using Helm, but it's a little weird. You won't get Kubernetes versions the moment they come out, but usually within a month or so, then Azure Kubernetes Service has that available on Azure, and you just pick it from the dropdown. When would I choose AKS? When I have many services that I need to spread out over a cluster. When I prefer open source. When I have an ops team on staff that can handle that Kubernetes management piece. And when I want bleeding edge Kubernetes content. Next up, Azure Container Instance, or ACI. ACI is great for creating mechanisms that just launch containers. Azure Container Instance is just an API for launching containers. It doesn't have a mechanism of auto restarting. It doesn't have a mechanism of scaling or load balancing, dependencies. Azure Container Instance is just a REST API for starting containers. Now that can be great if I want to build a system on top of that, where perhaps I have a service that allows tenants to spin up content on my system, and I just reach out to the Azure Container Instance API and spin up those containers as I need them. Now there's no auto restart or auto scale. It's just a cloud native primitive of running containers. Let's dig into Azure Container Instance. So we have this container in our Azure Container Registry. So let's do this. Now this command is kind of heinous. But it's one big long command. Azure Container create -name Rob Rich Docker in Azure, resource group Kubernetes, the image, the one that we just built, the registry username. I have a variable set on my machine. Same thing with the password. The ports, I'll just forward port 80 and give it a DNS name. Now that will take a little bit to spin up, but while it's spinning up, let's go to that URL and take a look at it. So Azure Container Instance. Now the cool part about Azure Container Instance, oh, I haven't seen it spun up yet. Resource group, Kubernetes. There it is, my container instance. It's on the way in. Waiting. Nice. Now it does take it a minute to spin up, but it's on its way in, and that's really fun. Let's give it a minute to fire up. Go, 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 go. I love how quickly it is to spin up. You know, if you could think of the amount of time that it would take to, fire up a machine in the past, rack a server, install Windows, get IIS installed. And now we've got it. Here's our URL, and let's go there. Here's our container running in Azure. Very nice. Welcome to Global Azure Spain. Now, I can take a look at my containers. AZ container list -o table. Here's all of the containers that I spun up through Azure Container Instance. There's just the one. So now I can take a look at AZ container logs. Let's go grab the logs for this particular container. There's the console output for my application. That's great. And now when we're ready, we can go delete this. Let's go delete that container out of Azure Container Instance. And now, refresh. It's gone. Perfect. As easily as I can spin it up and spin it down, I can now consume these. These are billed per second, and it's really great. I don't need to worry about any of the pieces underneath. Let's go look at the containers that we have now, and our list is empty. Perfect. Another way that we can create an Azure Container Instance is to come in here. Let's come back to here and our Azure Container Registry. Inside here, repositories, I will pick my repository, and then I will come in here and I will say run instance. Now the beauty of this is that it will actually spin up a container instance for me, let me pick all of the details, and I can just push go. The beauty there is that I now, from my registry, can just spin it up really fast and see if that one's the one that I want. In this case, we'll choose not to run it. Azure Container Instance. Azure Container Instance is so much fun. With Azure Container Instance, we outsourced all of the pieces of running the container. The host infrastructure, the VM patching, how many worker nodes did we have? It doesn't matter. We just have one big pool. We choose to own the container process. We own the container health and restart. So if our app crashes, then we need to run the command to restart it. And scaling, we need to choose to scale by launching that REST API again. Azure Container Instance is great for utility billing, when we don't want any infrastructure to manage. On the downside, we need to do the auto scaling and auto restarting piece. Azure Container Instance is great when you want to build a platform on top of it where you have multi-tenant content and want to build a mechanism for spinning those things up. It's also really great to quickly test a container. Is this what I want? Right-click, run it inside Azure Container Instance, and it works out just fine. Now there's a great project called Virtual Kubelet that is marrying the Azure Kubernetes service and the Azure Container Instance together. So we'll have now a one big virtual node that is Azure Container Instance inside of our Azure Kubernetes service. At that point, I can maybe have one or a few nodes inside my AKS and the rest just run in ACI. That is really cool. I can't wait to see Virtual Kubelet come online. It's in preview now. Azure App Service. So the next thing we can do is run containers in Azure App Service. Now, Azure App Service is the platform as a service mechanism where I may choose to run .NET or Node or Python apps. But I can also run containers. With Azure App Service, I deploy a single container and it auto restarts like any other IaaS app. It works in both Windows and Linux containers. It's no longer in preview, and it does really well. So let's dig in and do an Azure App Service deployment. So I'm going to come in here to Home. Nope. Dashboard. That's where I'm after. Nope, not that one. That one. Create an Azure App Service. Okay, I want a new Azure App Service. And now I'm going to choose my resource group. I'll choose Kubernetes. What's my web app name? RobRich27. Is that going to work? Yes. Nice. Select a runtime stack. I would like a Docker container, please. Linux, that's fine. I'll choose East US. East US. And I've got an app service plan in place. Do I? Nope, I don't. I'll create a new app service plan. I can choose to change the scale of this app service plan and pick the amount of memory that I need for these containers. Next, I will choose Docker. Now I'm going to choose to run a single container. I love that they're going to support Docker Compose. And I'm going to go pick my Azure Container Registry. Here's my registry. I'll select my image. There it is. Select my tag. I'll grab v0.1. And my startup command is actually baked into my container, so I'll leave that blank. Now I could choose latest. And the beauty of choosing latest is it actually creates a webhook inside of Azure Container Registry. And whenever you push, it will just automatically update your website. That's really cool. If you want to, instead, you can pick a particular tag, and now it will be quite stable. It won't be polling against the Azure Container Registry. I can then go through the rest of the pieces and ultimately create my site up here on Azure App Service. Now, the only difference between this content and any other content running in Azure App Service is this just happens to be in a container, which means I have full control over all of the pieces inside of my application. That was really cool. I can put a config file exactly in that directory where I need. I can install all of the software that I need. I just package it up as a container and start it inside Azure App Service. Inside Azure App Service, we've chosen to outsource the host infrastructure, VM patching, container health and restarts, container scaling. All of that is managed by Azure. We just need to drag a slider if we want to scale up or down. We still own our container process, but all of the other pieces are managed by Azure. That's really cool. When would I choose Azure App Service? Well, Azure manages everything on this one. That's really nice. It has drop-dead simple scaling. I just grab the slider and scale 2 instances, 4, 8. On the downside, it only runs a single container and only on a single port. So if I have many services, I'm going to end up with many web apps. And now I may blow out my app service plan. I might need to upgrade to Azure Kubernetes Service instead. But if I have a monolith that I just need to publish, a monolith inside of a container on Azure Web App may be perfect. Azure App Service. When would I choose it? If I want to modernize a monolith, I can jam that monolith inside of a container, and whether it's a Windows or a Linux container, I can run it here in Azure Web App. Next up, we could choose to install Docker or Kubernetes in virtual machines. This is definitely the maximum amount of things that we can control and own. And so, well, we just provision a bunch of virtual machines. Maybe we join them as part of a VLAN. And at that point, we can just install our orchestrator of choice. At this point, we manage everything and we control everything. If we need a very specific version of Kubernetes, then this might be a really elegant choice. In this case, we've chosen to outsource, well, pretty much nothing. Really only the hardware underneath the virtual machines. We don't need to buy and rack hardware anymore. But all of the installation, configuration, patching, container health, cluster health, scaling, all of those pieces are owned by us. If we want to increase the number of worker nodes in our Kubernetes cluster, we need to go provision another virtual machine and join it to our cluster. So installing Docker inside virtual machines. You can control everything. You upgrade only when you want to. On the downside, you must do it all. So installing Docker in virtual machines. If I have a hosting platform that I need to run in Kubernetes across clouds or identically on every cloud, then I may choose to provision virtual machines so that I can get that very, very consistent experience across all the clouds. Docker in Azure. Let's take a look at all of those compute platforms and see when it was effective to use each. What do I want to manage? From the most managed to the least managed. App Service was completely managed. That was wonderful. Service Fabric is pretty close there too. Azure Container Instance in the middle, Azure Kubernetes Service, and finally virtual machines where it was the least managed. I got the most control out of everything. On a scale of many containers to few containers, when would I choose this service? If I had many containers, I might choose Azure Container Instance because now I can control all of the pieces and only pay for per second billing. Next up, virtual machines. Virtual machines allow me to scale as much as I need, and I just go grab another machine. Azure Kubernetes Service gives me that same level of configuration, but I can start to auto scale down if I have fewer containers. Service Fabric comes in next. Azure Container Instance for dev test is really great if I have a few containers because I can provision them really, really quickly. And then finally, App Service. App Service only lets me run a single container. So if I need multiple containers, I would have multiple App Service apps. Here's kind of that table. And if you're ready to take a shot with your camera, this is the screen to grab. All of the technologies, do they support Windows and Linux? They all do. Their pricing models, their auto scale mechanisms, their auto restart mechanisms, and how much of this do we own? The cool part here is that we have lots of options here on Azure. Azure can definitely meet you where you need to be. Whether you want to take control over running all of your content, or whether you want to outsource all of that, or whether you want kind of in the middle. Whether you have lots of containers to run, lots of microservices, or just a few containers, a modern monolith. You can meet Azure where you are, and Azure can hold that compute in place. It's so much fun getting to show you all of the different ways to run compute inside Azure and all of the different ways to host containers. I'll be in that spot where the conference has designated Q&A. But if you're watching this later or you have a question tomorrow, grab me on Twitter at rob_rich. And you can grab these slides right now at robrich.org. Thanks for joining us on this tour through all of the spots where you can run containers inside Azure. Thanks for joining us.